Assalamu alaikum. The topic of today's video is the relationship between delta H and delta E. Delta H, as you know, is the enthalpy of a system, and enthalpy is the heat content of a system at constant pressure, and delta E is actually the change in energy of a system. So according to the first law, the value of enthalpy is given by delta H is equal to delta E plus P delta V. Here, this is the work done on the system. So, in case of solids, when the work is done on the system, the change in volume is nearly equal to 0. So when delta V is equal to 0, so taking this part to be equal to 0, pressure multiplied by 0 becomes 0. So what we are left with is delta H is equal to delta E, because this part has just become equal to 0 because of delta V equal to 0. So I can say that delta H and delta E are the same in case of the solids and also the liquids, because in case of liquids the change in the volume is also very much negligible. So in case of liquids also, I can write just like that: solids and liquids, the change in volume is nearly equal to 0. So delta H and delta E are the same. However, when we talk about the gases, in case of the gaseous reactants and products, delta H and delta E are quite different. So for gases, for a reaction involving the gases, let's just say for gases, the N1 is the number of moles of reactants, N2 is the number of moles of products. So now, according to the general gas equation, the general gas equation is the ideal gas equation is given by PV1 is equal to nRT. So N1 is the number of moles of reactant. So I can say that if I am taking V1, then that would be N1. Similarly, if I'm taking V2, then that will be N2 RT, because during the course of the reaction, the reactants has changed into product. And during the course of the reaction, when the reactants has changed into product, the number of moles has changed from N1 to N2. Similarly, the volume has changed from V1 to V2. But we have not changed the pressure. We have not allowed the pressure to change, because we are talking about the enthalpy, and enthalpy is measured at constant pressure. So that's why we have not allowed the pressure to change. So now taking the difference, that will be equal to PV2 minus PV1 is equal to N2 RT minus N1 RT. So now what you have to do is to take pressure as common. That will give me V2 minus V1, and then I have to take RT as common, and that will give me N2 minus N1 RT, and I can write it as P delta V is equal to delta N RT. So now going back to this equation, delta H is equal to delta E plus P delta V. I'm going to write this equation again. Delta H is equal to delta E plus P delta V. So you have just calculated the value for P delta V, and that is delta N RT. So delta H is equal to delta E plus delta N RT. So now, as you know that in case of delta H, the pressure is constant. So I can write delta H as QP. Delta H is actually the heat content of a system when the pressure is constant. Similarly, delta E is actually the heat content of a system when the volume is constant. So now the next thing is delta N RT. Okay, so this equation represents the relationship between delta H and delta E of the gases. So that's the final equation. So if you have any question, you can ask in the comments. Thank you and Allah Hafiz.